Hello everyone, and welcome back to another video. So today we're talking about this little unassuming card right here. This is an OEM RX 580 8GB, and I got this for super cheap. I think I paid like 30 euros, maybe 35 including shipping, like very cheap. Because the owner sold the card as dead, no image out. And when I got the card, I noticed that there is image out and the card works perfectly fine. There is no issue with the card. So I suppose they had like a dead HDMI cable or something, because like the card just works. I didn't test all the outputs, but like yeah, at least one of them works. So yeah, so I now have an RX 580, and this is like an OEM card as seen by the blue PCB and the very rather anemic looking heatsink, though surprisingly like this is a pretty decent heatsink. Like it's only 2 heat pipes, only 1 fan, but this wasn't going above 70 degrees. I think it went above 60, but like it's not bad. Admittedly, I'm at stock power limit, which is like I think 110 watts or something, but yeah, better heatsink than I thought it would be. And yeah, so it's a reference PCB, though it is blue, and we can take a look at it because I already took the screws out. Yeah, it's just a reference PCB, RX 580, or more like, I don't think AMD ever sold like an AMD version of the RX 580. They did it for the 480, where they just had a straight up reference card that you could buy. I think for the 580 it was like only custom models. So getting a reference PCB 580 is kind of not that easy, but it is just a RX 480 PCB with a 580, because a 580 is just like a slightly overclocked 480. It's the same card. So yeah, this is the same PCB that you would get on a reference RX 480. Which means it has a really strong 6-phase. This doesn't look like much, but this is a really strong 6-phase. This should be VDDCI, that should be memory, that's probably PLL. And are there even other rails on this? There might be like some low dropout regulators, but yeah. Like, main point is 580, it's working, it's an 8GB one. It is the reference PCB, which is like that VRM is gonna take whatever you push into it. And it being the reference PCB also means that it's running off this thing, the IR3567B. This supports I2C. And I've been told that this right here, these 3 empty pads, which are labeled J4001, I've been told that this is just a I2C hookup point. So you can just solder 3 cables to this, plug it into an Elmo EVC, and you have, well, full control per I2C over the IR3567B. So the 3567B controls at least vCore and maybe another rail. I haven't really checked. Bullseye has a PCB over breakdown of the RX 480. I guess I should watch that, and if you want some more details on the PCB, you can also watch that. It is a rather old video, but well, worst case I just make my own version with this card, but for now I'm not planning that. Yeah, so good VRM, I2C, like you can pretty much just like go right into it with this card. You don't need to do much. Now, in terms of cap mods, yeah, you could do some cap mods. There are some unpopulated, like, multi-layer ceramics here, but I really don't think it's worth populating this, especially, like, how hard it would be to do that. What I could see myself doing is, like, maybe stack some capacitors here on the back, and then maybe populate these empty pads, which, this should be memory. It is on Samsung chips, like, yeah, that's a Samsung chip. It is 8 gigabit. No, that's the wrong way around again. It is 8 gigabit B-die. Not the same 8 gigabit B die that's on DDR4 sticks. This is GDDR5, but it is also called 8 gigabit B die. Yeah, like I haven't worked with 8 gigabit Samsung before, like GDDR5. Generally, Samsung chips, from what I've heard, scale with voltage, which I can approve. Like I've seen a lot of Samsung chips scale with voltage. And another thing that Samsung chips do is sometimes, well, actually, it says that more often than not, Samsung chips don't like cold. I haven't had that myself yet, though admittedly, like what cards with Samsung memory did I have cold? Like I had a 580 and Samsung 1 gigabit eDie scales with cold, I knew that before. I can't really remember any other Samsung card that I've done Sub-Zero with before, so I don't really have a huge database on it, but I haven't seen negative voltage scaling on Samsung chips yet. However, it is a thing that apparently exists, which is why cards like the 780 Ti and the 290X Matrix from Asus and like some Kingpin cards from EVGA have an integrated memory heater to like heat up the memory chips while the core is at sub-zero temperatures, so that your chips don't lose as much headroom. That's a potential issue with the card. But it might not be. Like, it really depends on whether this chip specifically has that problem, and I have no way of knowing until I test it. And yeah, but like, other than that, you solder your 3 wires to the back of this, maybe put on some capacitors, though I really don't think you need to. Like, at least for core output filtering, AMD cards are usually fine. As of late, they've done a little bit of a bad job with input filtering, but like this input filter looks fine. It would be like a much more recent AMD card where you would have concerns about, like, this is, yeah, these are 270s. This is literally more input filtering than you get on a 6900 XT. Like that right here. And there's another capacitor right here. Like on a 6900 XT, I think you get 4 180 microfarads on the inputs, and then like maybe another 1 or 2 across the board. So yeah, this is more capacitors and more capacitance per capacitor than a 6900 XT. Just to kind of like give you an idea of how bad the input filtering situation is on some newer AMD cards, but this one is fine. And yeah, I have done some testing on this already. Only on the stock heatsink. I haven't, like, you can see how the VRM heatsink is like integrated into it, and I could probably run the VRM naked just with airflow, but I kind of want to have some cooling on the VRM. So I'm probably gonna like go find some Raspberry Pi heatsinks and thermotape this onto here, and then run it on water and then Sub-Zero eventually. Once I'm done with the current projects, which is the 960 and the 1060. 1060 is actually set up right now, has the phase change on it. I just need to run it. It's a bit late already. I might run it today, I might run it later the week. Like, I don't really find that much time benching as of late. But anyway. Yeah. So the testing I've done on this with the stock heatsink and also the stock BIOS, that means yeah, the power limit is rather low, the memory timings are stock, and yeah, that's pretty much it. So the card on the core does 1475, which isn't the best. I've heard of cards that do 1500 plus, but this again is at stock power limit and stock like BIOS, which means stock vCore, and I think the highest vCore that you can select is either 1.15 or 1.175, which isn't a whole lot, because in MS Afterburner the slider actually goes all the way up to 1.25. It just doesn't work because the driver overrides MS Afterburner and the driver only goes to like 1.15 or 1.175. So yeah, and this scales with voltage as far as I know. So if I had proper voltage control, this will probably do 1500 plus. Though at that point I'm probably also running into the power limit. So I also need a higher power limit BIOS, which shouldn't be that hard to get. I just haven't gotten around to it yet. But yeah, so like for now the core clock's not the greatest, but it's pretty good, I would say. Like this is already higher than my RX 570 ever did, even with like mods on it. And then the VCore VRM on that one blew up because that one was a crappy Asus 4-phase. Yeah. But yeah, so core seems decent. However, I can't really unlock its full potential yet. And the memory just maxes the slider in the driver. I'm not entirely sure as to what timing set it actually manages to run there, because I'm fairly sure I applied timing setting 2, which as far as I know is the tighter setting that has like higher performance per clock. And I was able to max the slider then. And then sometime after, I tried that again, and the card immediately started artifacting on desktop and crashed. So yeah, there's a possibility that maybe timing setting 2 was selected but not actually applied when I tested it the first time, because I'm pretty sure I selected it. Or there's just some funky thing going on with the driver in a different way, where like sometimes it's stable, sometimes it's not. So I'm not entirely sure if memory timing setting 2 on the memory is actually stable at maxed out slider, which is 2250 memory as far as I know, I think. So I'm not entirely sure how good that is, but like it is Samsung chips, they usually clock pretty good, at least in my experience. So yeah, it's a decent card. Like it has a lot of potential. Of course, I like the fact that it's an OEM PCB because you know it's blue. It could have been red, I think. Yeah, it's an AMD card. I would like a red PCB would have been a little bit more cooler. Like, I have a green 580. I do actually have a red 280X. Now I have... Well, I have some Gigabyte Fermi cards, which are also blue. But, yeah, I mean, it's something different than just, like, black or brown. Which, you know, is nice. It always looks nice in like, your pictures that you take of, like, oh, it's a kind of a special card, even though it is just a reference PCB. Which doesn't mean it's bad, it's just like not really that remarkable. The color is like the only special thing about it. Yeah. I guess that's pretty much everything I wanted to say about this. Like, overclocking wise, card seems pretty good. It has a lot of potential in it. I just need to get around to like actually do things with it. But like currently the 960 and the 1060 take priority because those are already modded and ready to go, and I've already benched them a bit, and all that stuff. But like this one's gonna be one of the next few projects. I will have to learn how to run AMD cards properly, like especially modern AMD cards. This still has driver support, or the other cards I had before didn't. Like 28 nanometer AMD is like dead, no more driver support, so the best drivers are just kind of known. For this one, new drivers will still come out, and yeah, there will be some testing. My RX 570 sadly is probably not savable because a high-step MOSFET blew up on it, and I repaired that briefly. Blew up the MOSFET again because I used the wrong... I didn't have the exact MOSFET, and the one I used was apparently worse than what should have been there. Then I blew it up again. Then I had the very good idea to e-power the card, which actually worked. Like it worked, but it wouldn't install the drivers because it's probably trying to talk to the VCore controller, which doesn't exist anymore. And I tried to solder the VCore controller back on, and the card doesn't work anymore. Like I broke something, either the controller or like something around it. So unless I find out how to e-power my RX 570, that card stays dead. But now I have this at least, which is, you know, a 580. It's got a slightly faster core. It's also an 8 gig. My 570 was a 4 gig, and it has a much stronger VRM. And also, like, you know, I2C, because the 570 was on like a Rich Tech something controller, which probably does I2C, but probably isn't as good as a 3567B, because this controller I think was made for the 290X. Yeah, like it just generally, this should be a much more higher end controller than whatever the Rich Tech thing on the Asus card was. That should really be it. 15 minutes, that's a good length for a video. So yeah, I hope you enjoyed my rambles about this thing. You're gonna see it sometime soon, though my definition of soon is rather flexible. But yeah, so I'm looking forward to that. I hope you are too, and until next time, goodbye.